Presently, HDFC is banking very low interest rate, personal loans, or it is going to give with respect to the credit card offer with no documents, something you are going to have. Some word will be there, the words which will attract. They are going to create the words which will attract. If they say that, please apply for this bank and you'll get a credit card after processing. If you are a valuable customer, if you are a very good customer, only will give the credit card, means who will apply? None of them will apply. They have to send a SMS that you will get on Swiggy with respect to instant discount of 400 rupees using this card. Oh, what is this Swiggy? We'll try and we'll click on that. Some words, they are identifying that common words which are in the trending and which makes the people attract, right? And since it is in the inquiry list, they are going to send a different SMS. For example, you have applied already, but your loan has got rejected. Immediately they are going to send with respect to an SMS that this particular bank is offering with a low interest rate. And you are going to get some kind of SMS that this particular other company doesn't require any loan documents. When your loan has got sanctioned, everything was sanctioned. Now you are going to get transfer the loan from this account to another account. You will get one more SMS like transfer your loan, like portability. How we are having the mobile number portability, same way, right? So different types of SMS we are going to get, and different types of marketing they are going to do, right? So in the banking industry and in the retail industry, they are going to identify the patterns of the customers. Which are the common patterns of the customers? What is the buying patterns of the customers? Here they are not going to predict whether you will purchase or not. They are just observing your pattern. What are the past data is that they are observing the pattern. They are not predicting. They are not making any kind of prediction, right? So for example, recommending a new books, recommendation engines also comes under unsupervised machine learning, and that we are going to see in the next further, right? So in the insurance, in the retail industry, all these industries will use this clustering applications. Now, how this clustering will be done? We are having different types of clustering algorithms, out of which the first one is called as K-means clustering. Similarly, how we are having the KNN, we are having the K-means clustering. Now, what is the difference between KNN versus K-means? KNN is used for classification. K-means is used for the clustering technique. KNN is applied on the labeled data. K-means is applied on the unlabeled data, right? Now, let us observe this K-means algorithm. So let us observe the K-means algorithm. Now in the K-means algorithm, we are having the data points like this. Just we have to group them. So the K-means algorithm is also called as partition clustering. And the K-means algorithm is a non-overlapping, means it is not going to have, for example, one record is there. One record will belongs to both red at the same time blue. It will not be like that. It belongs to either one of the group only. So for example, there is a one person is there, means he has to belongs to either that group or this group, any one group. We can't say that he belongs to the both the groups, any one. So K-means divides the entire data into non-overlapping subsets. The entire data will be divided. Okay. And coming to this, examples of within the cluster are very similar. Examples across the different clusters are very different. Means whatever the records are within the cluster, whatever the records are there, these will be very similar to each other. These records are very similar to each other. These records are very similar to each other. These records are very similar to each other. Now these records are dissimilar. Okay, is that clear? Now here we are having with respect to two types of distances. One is called as intra, one is called as inter. Intra means within the group, whatever the distance is there. Within the group, whatever the distance is there, it is called as intra. Outside the group, between two groups, the distance is there. That is called as inter. Okay. So for example, let us take like this. Okay, their group of students are there. Their group of students. Groups of students are there. Various groups are there. This is one group. This is one group, and this is one group. Okay. Now let us assume this group is CSC group, and this is mechanical group, and this is EC group. Okay, in the BTech. Okay. Now CSC group, whatever the students are there within the CSC are very similar because they study the CSC on. All of them they study the CSC. Mechanical group students studies the mechanical related subjects. EC related group students will prepare the EC related subjects. So all the group students, whatever these, now you can't bring the mechanical student into CSC. You can't bring one of the mechanical student and you can't keep in the CSC. So CSC group, for example, in the WhatsApp groups we are having, right? In the WhatsApp group, CSC group is there. What is meant by CSC group? All the students belongs to CSC background, computers background. Mechanical group is there. WhatsApp group, mechanical group is there. What is the meaning of this? They all of them belongs to mechanical group. So EC group is there. They belongs to EC group. So the students are very similar to each other. Within the group, they are similar to each other. Between the groups, they are dissimilar to each other. Is that clear? Within the groups, whatever the students are there, they are similar to each other. But with compared to other groups, they are dissimilar. And within the group, whatever the students are there, those distances, whatever the distances between the students are there, the distances should be low. If the distances are low, means they are very close to each other. Within the group, the distances should be low. When compared to between the group to group, the distance should be high. Okay, between the groups, two different groups, the distance should be high. Within group, the distance should be low. Means they have to be very close to each other. So one is called as intra. Intra means within the group. Within the group, what all the students are there, these students' distances should be low. Outside the two groups, between two other groups, it should be high. For example, let us assume this is the different college students are there. This is college 1, college 2, college 3. One more example. Now within this college, all the students should be on one. They should have a team. They are one team. They can't, within this, again, they can't subdivide. These college students, whatever the college 1 students are there, they have to be as one. Okay. And they have to fight for one. For example, this is the college 2. They are internally one. But between two different colleges, the distance is high. Is that clear? Example, just I'm saying example from the college or group's perspective. Here we are going to see the records perspective. Okay. Now, so here next, how to calculate the distance? Just by applying the Euclidean distance. For example, if you are having only one column with you, only one column, each column is there. 24, 29, 23, 24, 24, 26, 32, 38, something you are having like this. How to calculate the distance between 2 points means you are having only x variable. So square root of x2 minus x1 whole square. That is 24 minus 29, 24 minus 23, 24 minus 24, 24 minus 24. Any two data points you are going to consider and you are going to check. For example, I want the distance between this person versus this person. What is the distance between these two? Means you are going to take square root of 26 minus 38 whole square. That is with respect to 12 whole square. Okay, minus 12 whole square, minus 12 or plus 12. Answer is same. Whole square, and you are going to get 12. The output will be 12. Minus or plus, anything is same, right? For example, you are having two columns, column 1 and column 2. One is age and one is experience. 22 0 years of experience, 21 0, 23 1 year of experience, 29 4 years of experience, 30 4 years 6 years of experience. Now, what is the distance between the record 1 versus record 2? Means square root of 22 minus 21 whole square plus 0 minus 0 whole square. What is the distance between the first record versus fifth record? Miss square root of 22 minus 30 whole square plus 0 minus 6 whole square. What is the distance between these two records? Miss square root of 29 minus 30 whole square plus 4 minus 6 whole square. Since you are having two variables, x and y, two variables are there, you are going to consider x1 minus x2 whole square plus y1 minus y2 whole square, right? For example, you are having the three columns. Let us assume I am having the three columns. Instead of two, I am having three. Third column also is there. Income 6 lakhs, 2 lakhs, 9 lakhs, 12 lakhs, 1 lakh. Now you are going to take the square distance between first record versus fifth record. What is the distance? 22 minus 30 whole square plus 0 minus 6 whole square plus 6 lakhs minus 1 lakh whole square. Right? So what are the columns are there? Each column minus you are going to do. The same thing I have represented in the PPT also. Okay, so here I'm having only one column. The column is age column and two records are there. One is for 54 and 50. So what I'm going to do is square root of 54 minus 50 whole square. That is 4 whole square, 4. I'm going to get 4. Next, for example, I'm having columns. Two columns. One is age and one is income. Now, here I'm having two columns and two records. How to calculate the distance means 54 minus 50 whole square plus 190 minus 200. Is that clear? Square root of. Next, if I'm having the three columns, 54 minus 50, 190 minus 200, 3 minus 8 whole square. Okay. How many columns are there? That many. Next. Now, before to K and N, you are having a data like this. Before to K and N, the data points. If you apply the scatter plot between, assume you are having only X1 and X2. Only two columns are there. Only two columns. There is no even output variable. There is no output variable. Only two columns, input variables, X1 and X2 are there. And I'm having the data points like this, some of the data points. And for these data points, if I apply the scatter plot, I have got a scatter plot like this. Now, I have to apply the K and N. K-means. I have to apply the K-means algorithm and I have to separate them and I want to group them. How I'm going to do this? How I'm going to group this data points means after grouping the data points, I'm going to get like this. These all of them belongs to one group. This belongs to one group. These belongs to one group. And that too, it is three groups. How I have decided number 3 is point number 1. That is one of the most important point. How you decided 3. And for example, 3 you decided. Why you have considered this person to this group only? This one you can't consider like this. And this one okay. Now why you can't do like this? Why you have to do in this way only? Why you have to create a groups in this way only? How it is going to work? The process, how it is going to work in order to understand that. So please take a note of these points. We'll see one by one. I'll explain one by one, step by step. What is Done? Completed, guys? So completed. So let's see that how it is going to work by one of the example. For example, I'm having here, this is the data points. Let us assume these are the data points. Now these data points, first step, choose the k number of clusters. Point number 1, choose the k number of clusters. That is, I'm going to choose the k is equal to 2. Now here we are going to take from k is equal to 1. How in the KNN algorithm? If you remember the KNN algorithm, first we are going to take k is equal to 1. And after that k is equal to 2, after that k is equal to 3, k is equal to 4, k is equal to 5. Like this, we are going to try with the different k values. And later we are going to identify which is the best k value. Similarly, here also we are going to do the same. Okay, choose number of k. There is k value is not always fixed. We have to try. For example, if I take the k is equal to 1 means everything will be considered as one cluster. No need to do the clustering also. Separately, no need to do clustering. Okay. So k is equal to 1 means you don't need to do separately clustering. Minimum k is equal to 2. Minimum clustering means you have to divide into the groups means minimum 2 groups. Minimum. This is the starting. Ending is with respect to 3 groups, 4 groups, 5 groups, like this you can do. Now, first k is equal to 2. First, I'm going to start with the k is equal to 2. Now, once I have taken the k is equal to 2, select k random points. So take any 2 random points. Step number 2. What is the step number 2? Take any k random points. That is k random points means what is the k value I have assumed? 2. So randomly you choose any 2. Randomly. There is no rule which one you have to choose. And that it should not be not particularly in the data set. Means exactly this data point only you have to select or this data point. There is no rule like that also. You can choose whatever you want. For example, I'm choosing these other 2 points. Okay. Now, after choosing the 2 points, what is the step number 3? Assign each data point to the closest centroid. Now, whatever the 2 random points I have assumed, the 2 random points, whatever the assumed points, I assumed the centroid points. I have assumed those are the centroid points randomly. I have chosen randomly centroid points. I have chosen randomly. And what I'm going to do is I'm going to assign each data point to the closest centroid. For example, this data point is there. This data point, I'm going to calculate the distance to this centroid. At the same time, I'm going to calculate the distance to this centroid. Which distance is low, that one I'm going to convert to that color. For example, this data point is there. This data point is close to red data point or blue data point. It will be close to the red data point. So convert to red color. Now this data point is close to red or green, red or blue, red color. This one, red. So now for each data point, you are going to calculate. Whereas this data point, it is close to blue. So whichever is close to, just how to check the whether it is close or not means distance formula. By applying the distance formula, you are identifying which are close to each other, and based on that, you are going to assign each data point to the closest centroid. Like this, you have assigned to the closest centroid. But okay, as you have assigned all the data points, you have assigned red data points, blue data points. Now, what is this red point? First red point, and what is this blue point? I have taken red point and blue point, right? What are these 2 points? 2 centroid points. 2 centroid points which are assumed, not original. They are assumed. Now, really they are center. What is meant by centroid? Basically, centroid means which is in the center. Whether they are in the center, I'm going to check. How to check whether they are in the center means whichever is in the blue color data points, which are blue color. For all the blue color data points, I'm going to identify the center point. How to identify the center point for all the blue data points means x1 plus x2 plus x3 plus x4 plus x5 like this divided by 5, y1 plus y2 plus y3 plus y4 plus y5 divided by 5. For example, you are having 5 data points with you, 5. 3 data points are there means 3. 2 data points are there 2. For example, I'm having, let us assume these are the 2 data points. This is the first one and this is the second one. For this, I want to identify the centroid. Centroid means center between them. What is the center value between them? x1 plus x2 by 2. Similarly, y1 plus y2 divided by 2. This is the center point. For example, 3 points are there. For these 3 points, what is the center one? x1 plus x2 plus x3 divided by 3. y1 plus y2 plus y3 divided by 3. If I'm having 4 data points with me, what is the center for these 4 data points? x1 plus x2 plus x3 plus x4 divided by 4. y1 plus y2 plus y3 plus y4 divided by 4. Similarly, now here all the blue data points are there. 1, 2, 3, 4, 5, 6. 6 blue data points are there. For these 6 blue data points, I'm going to identify the center value. Similarly, for the red data points, 1, 2, 3, 4, 5, 6, 7, 8. What are the 8 red data points are there? I'm going to identify the center value for this one. Okay. Now, this is the center value. Now, assumed value is different and calculated value is different. Both of them are different. Assumed value is 1. One blue point, I have assumed something. Now, calculated value is a different location. So, I'm changing to the different location. So, now the blue point has been shifted to this new data point. Now, since the blue point has shifted to data point, now this data point, once again, I'm going to calculate for each distances, whether still they are in the blue or red. Okay, still they are blue or red. Now, what I'm going to do is, again, I'm going to calculate this data point is close to the blue, whether this data point is close to the red. Now, after calculating now, once again, now I have identified earlier these 2 data points are very close to the earlier these 2 are close to the blue, but this time these 2 are close to the red. Now these points has been converted. Earlier it is different, now it is different. Okay, don't get confused. I will explain in simple words once again. For example, there is one student in this class. I assume that student is a good boy. I assume the student is a good boy and I have taken that good boy into a good group. Okay, by considering him as a good boy. Later, now I'm going to check whether that group of the boys, what are the boys are there, whether they are good boys or not. I'm checking once again. In the check, if I have found anything wrong, miss, now I'm going to do the modification. First, I have assumed and I have thrown that boy, that particular person. Later, that is assumption. Initially, what I have done is assumption. First one is I am assuming the boy is a good boy. I am assuming that boy is a good boy and I have kept into the group 1 assume. Later, 2 or 3 days, after completing 2 or 3 days, I will see his behavior pattern, right? His behavior pattern I will see. At the same time, in the second group, I will see some of the bad boys. And I have assumed these are the bad boys. I have assumed. Now, after the observations, I will observe that, oh, this person is basically he's a bad boy, but I have wrongly kept in the good boy group. So I'll remove him. Here, is there any person like that? I'm going to modify. After the observation, I'm going to modify. Similarly, here also the same. So before to that, first you have taken is, just observe this one clearly. Okay. First you have taken is random points. For these random points, you are converting these into one group. This is according to you, this one group. How you created 2 groups like this, miss? Randomly you have created. There is no rule for this. Randomly you have created 2 groups. For example, your data points are like this. One data point is here, one data point is here, means this belongs to one group, this belongs to one group. As your random points changes, the groups also changes. The group of students will changes. The data will changes. The records will changes. Now what happened? Now I'm calculating. Now after calculation, before to calculation the data points and after calculation the data points, whether both the data points are same or not, I'm checking. Before I'm doing once I have checked by assuming the assumed centroids. With the assumed centroids, I have seen the data points. Which data points are one group? I have checked the points by assuming the centroids. After that, calculated. I have calculated the centroids. Now I calculated the centroids, and again I'm going to classify the points. Before I have classified the points, after that also I have classified the points. If these points are same to same, before and after, if they are same, miss, my assumption is a right assumption. If the points are different, miss, my assumption is a wrong assumption. Is that clear? Got the point? So first I have taken the assumed centroids. For the assumed centroids, I have classified the data points either blue or red category. And after calculating the actual centroid, again I'm going to check whether the points are same or not. If I check like this second time, now I have observed that this data point, now this data point and these two data points. These two data points are red data point. Now this point is converted to blue data point now accordingly. So some of the points has been changed. The original data points are not the same one. Points are changed. Now since the points are changed, my assumption is a wrong assumption. Now what I'm going to do? I'm going to change different assumption. This different assumption is this one. Now this is my new assumption. This is my new assumption. Now for new assumption, these are the new data points. New assumption, new data points. Now what I'm going to do? Again, I'm going to recalculate this original centroid. Now based on the centroid, again the points are getting classified. Like this, I'm going to modify. After doing all that time, when the points will be stable, though I change the centroid also, still the points are stable. Till that I'm going to work. When the points are stable, now my assumption centroid and calculated centroid both are same. Since both the centroids are same, this is the actual group. Finally, I'm going to conclude in that way. So like this, I'm going to group the records. Is that clear, guys? That is the process of k-means. So just you are going to convert like this, continue till you get the final one. Now you just observe the points which you have written in the notes. Step number 1, assume the number of centroids. I have taken number 2. After that, step number 2, randomly choose. I have chosen randomly. After choosing the random data points, calculate the points which are close to the random centroids. To the random centroid, calculate the points. That is the step number 3. Step number 4. Again, recalculate the actual centroid. That is original centroid. Now, original centroid and assumed centroid, if the both of them are same, till that continue the process. And whenever the both of them are same, stop the process. Now it is clear, step-by-step process. In that way, it is going to work. Now here, okay, sir, how to choose the number of clusters, k value? K is equal to 1 means, okay, k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5. For example, let us take like this. I'm having a data points like this 1, 2, 3, 4, 5, 6, 7. Only 7 data points are there. For these 7 data points, if I take into one cluster, k is equal to 1 means this one completed. Now k is equal to 2 for the same 7 data points. Same 7 data points are there. Now k is equal to 2. K is equal to means it is first randomly assigning one centroid like this. Randomly it is going to choose and later it is going to convert. And finally, I'm going to get these 1 into one group and these 4 into one group. Assume. Now next, same 7 data points. Okay. Now this time k is equal to 3. This is one group. This is one group and this is one group. This time it is going to take 3 random points. For that random points, it is going to convert to the nearest data points. Next, same 7 data points I'm considering once again. Out of 7 data points, now k is equal to 4. This is one group, this is one group, this is one group, and this is one group. Okay, next k is equal to 5. Okay, k is equal to 5. One group, one group, one group, one group, one group. Something it is going to divide like this, assume. Now like this, maximum how many number of groups I can get? What is the maximum? For 7 data points, 7 groups only is the maximum. Each data point belongs to one group separately. That is the maximum. Minimum k is equal to 1 to maximum k is equal to 7 is the maximum. Why? Because here I'm having only 7 data points. The reason is I'm having only 7 data points. For example, I'm having 700 data points are there. 700 groups is the maximum number. 1000 data points are there. 1000 groups is the maximum number, right? Now, here how I have to choose means the technique we are having here is called as elbow technique. Now, how we are going to calculate this elbow technique means first take the k is equal to 1. Start with k is equal to 1. By considering the k is equal to 1, now everything belongs to one group. Now this is the centroid. Calculated centroid and assume centroid. Everything is same. Now from this you calculate the distance. From each data point to each data point you calculate the distance. And do the sum of the distance square. For example, first one is this distance. Second one is this. Third one is this. Like this. First distance is 5. Second distance is 7. Third distance is 4. Fourth distance is 8. Now what you are going to do is sum of 5 square plus 7 square plus 4 square plus 8 square. You are going to do the sum like this. Sum of the squares of the distances. Each distance square, and you are going to do the sum. Okay, for k is equal to 1. Now after k is equal to 1, now try with the k is equal to 2. For k is equal to 2, how many centroids will be there? 2 centroids will be there, and 2 groups will be there. For this group, this is the centroid. For this group, this is the centroid. For this group, separately calculate the distances. Sum of the squares of distances separately. Within this group, you calculate the sum of the squares of distances separately, and take that value. Now that value is called as WCSS. WCSS means W means within, C means cluster, S means sum of. One more S means squares of distances. Within the cluster, sum of the squares of distances. Within this cluster, what are the sum of the squares of distances are there? Within this cluster, what is the sum of the squares of distances are there? You are going to calculate the sum of the squares of distances for the first one and for the second one. Now, later you are going to calculate for the third one. You are having the third one. Calculate that one. For example, if you calculate this one, now distance. Square of the distances. Distance. You are going to calculate like this. And from here also you are going to calculate the distances. Like this, you are going to calculate the distances, sum of the squares of the distances. Now, from this next, what you are going to do? Now, using this one. Now, for example, if you observe, for example, I'm having like this 1, 2, 3, 4. 4 data points are there. If I take as k is equal to 1, this is the centroid. Assume this is the centroid. For the centroid, I will get the 4 distances, and I'm going to calculate the WCSS for k is equal to 1. What is the value? For k is equal to 1, what is the WCSS value? Next, once this is completed, now I'm going to do the k is equal to 2. This is the centroid 1. This is the centroid 2. And this is one group, and this is one group. Now I'm going to calculate the sum of the squares of distances of this. K is equal to 2 WCSS. Next, I'm going to calculate once this is completed. Now I'm going to calculate the k is equal to 3. That is, this is one distance and this is 1, and this is 1. So here only one record is there. The one record for that, what is the WCSS? That is the centroid, and that is the point. Then what would be the WCSS value? What would be the distance? 0. Simply it is going to be 0. And here it is also going to be 0. Here the distance of this one and distance of this one square you are going to take. K is equal to 3. WCSS you are going to take. For this cluster 1, what is the WCSS? For cluster 2, WCSS, this 3, and you are going to add 3 of them. Plus you are going to do. Now after this, now finally the last one, that is K is equal to 4. So K is equal to 4 means this is the 1, 4 groups. Now what would be the distance of WCSS of this one? 0. This one 0. This one 0. This one 0. If you add everything, automatically it is going to be 0. Finally, the answer is going to be 0. When the number of data points and number of clusters are equal, the WCSS is going to be 0 simply. Right? Now, what I'm going to do is just I'm going to make a curve. I'm going to create a curve. This is the curve. Okay. In this curve, I'm going to create the curve between number of clusters versus WCSS. Number of clusters on the x-axis versus WCSS on the y-axis. For K is equal to 1, what is the WCSS value? For K is equal to 2, what is the WCSS value? For K is equal to 3, what is the WCSS value? For K is equal to 4, for K is equal to 5, for K is equal to 6, 7, 8, 9, 10. Every time the WCSS decreases. As the more number of groups are there, the distance between them will be decreased. For example, in this class, if I want to bring all the students into one group, miss, it is difficult. If I want to separate the groups, miss, if I separate each of them, separate group, miss, they'll have easily. Okay, the distance between them will be very less. So as more number of groups are there, the WCSS value decreases every time. Every time it will decrease. Now, how to identify the optimum number of clusters, miss? Elbow. So here, which is having the elbow technique, where you can observe there is a almost a flat line from where is the starting point, where you can apply the flat line. That one is called as optimum number of clusters. This one is the optimum number of clusters in this example. Okay, the line where you can observe a complete flat line is called as optimum number of clusters. Okay, sir. Line where the line you can observe the almost a flat line. This is the starting point is called as optimum number of clusters. Tell me what is the reason why we have to consider that one only. Because if you observe here, tell me for K is equal to 1 from this diagram. From this diagram, what is the WCSS value? It is approximately 8,000. Okay. Now for K is equal to 2, what is the WCSS value? It is approximately 3,000. For K is equal to 3, what is the WCSS value? Just 1,000. K is equal to 4, what is the WCSS value? Approximately 900. Now K is equal to 5, WCSS with respect to 800 or something. Okay, something you are having like this. Now, if you observe the difference from K is equal to 1 to K is equal to 2, how much WCSS has been decreased? 5,000 decreased. From here to here, how much it has decreased? 2,000 decreased. From here to here, 100, and from here to here also 100. Means there is no much difference. WCSS drop is nothing more. There is no much drop. If you subdivide into multiple groups also, WCSS is not impacting. So from where the WCSS is not impacting, that is the best WCSS value, and that is the best optimum number of clusters. Now, so here you have identified this one very easy. Now I'll show you one more example. Okay, I'll take one more example. And for this example, you tell me what is the optimum number of clusters. I will show you only WCSS values. Okay, these are the WCSS. K is equal to 1. For K is equal to 1, So 2,69,981 is there. For K is equal to 1,81,363. If you observe the difference, what is the difference between them? Approximately 87,000. Approximately 87 or 88,000 approximately. Now K is equal to 3. 1,06,348. Now what is the difference between them? 1,81 minus 1,06. 75,000, approximately 75,000. K is equal to 4. 73,679. What is the difference between them? Approximately. It is approximately 67. Okay, sorry, 33. It is approximately 33. Okay, done. K is equal to 5. 44,448. What is the difference between them? 29 something. Now K is equal to 6. 37,265. What is the difference? Approximately only 7,000. Approximately 7,000. Okay. K is equal to 7. 30,265. Again 7,000. So here the difference is 7,000, and here also the difference is 7,000. By decreasing, if you add one more group, there should be a large more difference should be there. But here there is no difference. Now by adding 6 or by adding 7, there is no use. So what is the optimum number of cluster? With respect to 5, wherever the starting point is there, that one. From where you have not observed the change, that one. So here, from here to here, 7,000. Again, from here to here, it is 7,000 is the starting. This one is the optimum number of cluster. So here it is 5. And in this example, if you observe this one, 8,000, 3,000, 1,000, 800, 900, 800. Now the difference here is 100. Again, the difference is 100. From where it is started? Here. So what is the optimum number of cluster? Means 3 is the optimum. Is that clear now? And from the elbow curve, we easily can identify wherever the flatness is there, the starting point of the flatness is called as optimum number of clusters. Right? Now, so in this way, we are going to identify the optimum number of clusters. And there is a problem in the K-means. There is one problem. What is that problem? Is random initialization. If you randomly initialize, you will get a different answers. Sir, how, sir? First, maybe randomly we may get initially wrong answer, but you are going to do the modification now. Multiple steps we are going to do, right? Again, how we get the wrong answer? Assume this is the data. Assume this is the data. For this data, I'm going to choose the K is equal to 3. Data is this one and K is equal to 3. Now I'm having with respect to 3 random points, I have chosen like this. Now for these 3 random points, I have got the 3 clusters like this. Now there is one more having like this. Now you are having 2 options with this. This one is there, this one is there. In this also 3 is the answer, in this also 3 is the answer. For example, 3 random points are chosen like this. 1, 1, 1 chosen like this means you'll get the answer like this. For example, you have your random points are chosen like this means. For example, your random points are chosen like this means you'll get. If your random points are chosen here 1 point and here 1 point and here 1 point means like this. Now out of these 2, which one is correct? 2 options are there. This is 1. 3 clusters. This is 1. 3 clusters. Answer is 3 only. Groups are 3 only. But data points are vary. In this, the data points groups are different. In this, the groups are different. The right data points you have not chosen. Now, what is the solution for this one? Miss K means plus plus. That is the solution. The algorithm is K means plus plus. Now, what is meant by K means plus plus means? So whatever the drawback I'm having in the K means, it is going to overcome the drawback. So how it is going to overcome the drawback means based on the weighted average. Do you remember in the statistics we have discussed arithmetic mean and weighted mean? Now centroid, earlier in the examples how to calculate the centroid I have told you. How to calculate a centroid? x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, where you have applied the arithmetic mean. That is called as arithmetic mean. You have not applied the weighted mean. Now you are going to take the weighted average. Instead of going with the arithmetic average, you are going to consider the weighted average is called as k-means plus plus. Now by considering the k-means plus plus, what happens means if more number of data points are there, it is going to give the more number of centroids in that location. If less number of data points are there, it is going to give the less number of centroids in that area. For example, I am having a data like this. Okay, a data is there like this. Now here, instead of considering two clusters here itself like this, now what it is going to do, here more number of data points are there, this side more number of data points are there. So two random points will be selected here, one random point will be selected here. It is not going to select two random points here. You can even select the two random points here itself, right? First random point, second random point. You can create like this and it can take only one random point here. It will not do in that way. Whereas in the k-means, there is a possibility because k-means is working on the completely random. Randomly it is possible means maybe all the three data points also possible here. All the three data points also possible here only. That is also possible. Okay, if that is also possible also for these data points, they are same now. So it is going to take like this. Okay, but now using the k-means plus plus, what happened means wherever the less number of data points are there, here it is going to initialize 1. Wherever the more number of data points are there, it is going to initialize here this one. Two random points will be initialized like this. Is that clear now? So by taking the k-means plus plus, it is going to take the weighted average. So let us see the coding part. Now here I'm going to take the first import NumPy and pandas and matplotlib, and I'm going to take the mall customer data. The data set is called as malls customer. Now in this mall customer data, I'm considering the what are the things are there means one called as customer ID. The second one is called as gender, what gender they belongs to. Third one is age. Fourth one is their annual income in terms of thousands of dollars. And the fifth one is spending score. These are the various column names I'm having. Now for these column names, whatever the column names and whatever the data I'm having, so I want to apply the clustering and I want to identify which customers are close to each other. Sir, why we have to do? For example, what is this data? This is the data. And in this data, total how many records are there? 200 records are there. If you observe the info says that total 200 records are there. Means total 200 customers are there. Now in this total 200 customers, I'm going to identify and I'm going to separate them. Why I have to separate? Question number 1. First thing, why we have to separate? If you separate means if you identify who are having with respect to, some people has annual income low, their annual income will be low, but their spending will be high. Though they get some small amount also, they'll spend completely, they'll spend. Some people they'll have with respect to annual income low, at the same time their spending also will be low. Both the people will be available. Similarly, some people will have high income. They'll have the high income. At the same time, their spending also will be high. Some people will have the high income, but their spending will be very low. Every possibility is there, right? Now I'm going to separate these people like this, who are having a high income with the spending score high, who are having with a low income and then spending score is low. For example, the persons are having a low income and the spending score is low means for these people, we are not going to share any kind of offers or nothing because they are not going to spend the money. Okay, they are not interested to spend the money. But for example, who are having the more interest towards the spending. Okay, though they are having less income also, but these people whose annual income is low, but their spending is high, why they spend more means because of the offers. Since the word offer is there, they are going to spend more. For high income people who are going to spend, for them no offer is there also, they'll spend. Irrespective of offer, they'll spend. For example, if you go to a particular shopping mall like GVK, right? In the GVK, we are having a GVK mall, one particular showroom is there. Okay, some kind of showroom is there. Now in this showroom, we have went. In the GVK mall, one person has went to a particular showroom. There, he will see with respect to whatever the different dresses are there. I mean, shirts, t-shirts, jeans, pants like this. He will just observe the things. And after observing, they are going to purchase directly. They'll not even ask any offer. Is there any offer? They'll not even ask. Whatever the MRP is there, they'll purchase. Even the shirt price is 8,000 rupees also, they'll purchase and they'll come out. But whereas some middle class people will be there. Their income is low. Basically, they are middle class people. They are not rich people. They are middle class people. Okay, middle or upper middle class. But their income is comparatively low when compared to these people. Their income is low. But still, they spend more. Because with respect to offers. With respect to offers. For example, in Amirpet, we are having some showroom called as KML Shopping Mall. You go to the KML Shopping Mall in Amirpet. 100% you will see the discount, the word called as discount. The same KML Shopping Mall will be in the Banjara Hills, but discount word will not be there. Discount word will not be there because that people are different. These people are different. Their income levels are different. These people income levels are different. Their requirements are different. These requirements are different. In the Banjara Hills, whatever Banjara Hills or Jubilee Hills, the shopping malls or whatever is there, they are going to keep with respect to very high level brand. Even 10,000 shirts also they will maintain. But whereas coming to the Amirpet, we'll have with respect to shirts of 1,000, 2,000, 1,500 like this. Completely, it is based on the people, the customers. Which type of customers are coming to for that particular shop, they are going to identify, and according to that, they are going to do the business. For example, very high rich class people are coming to Amirpet shopping mall, means automatically they'll also change accordingly. Okay, the completely it is based on the customers, what type of customers they are coming. Okay, so recently I have went to the DMart. Okay, few days back, around 3 or 4 days back, I went to the DMart. At the same time, I went to the Ratnadeep. Okay, in my area, Ratnadeep is available and DMart is available. So I have went to the DMart and I have made with respect to shopping and what are the required products are there, and I have taken off and I have came out. Now, 2 days back, unexpectedly for one of the item I want to purchase. So I went, instead of going to DMart, I went to the Ratnadeep. I have went to the Ratnadeep and I have observed the rates, means there is no discounts. There is no discounts. And the persons are purchasing also. The persons are purchasing. There is no discount. I have purchased one ghee bottle, which is of 1 liter ghee bottle. The ghee bottle, 1 liter cow ghee, which is of MRP is 729 rupees. In the Ratnadeep, what is the price? You know, it is 720. And the same in the DMart, the same 729, same company as it is 569 here. That is the difference. Now here, still there people are purchasing. Here also people are purchasing. Means these people don't know that in the DMart it is available for 569. Huh? What would be the reason? Why still in the Ratnadeep the people are purchasing? Means they don't know that offers are going on in DMart. They don't know everyone knows. Still, while they'll go to the Ratnadeep, that is their requirement. Okay, certain people will come to the Ratnadeep. In the entire Ratnadeep, including me and staff members, totally 8 members are there in the entire mall. In the entire supermarket, totally 8 members are there. Out of which I am one. 3 members are executives and others are 4 members, customers. Means total 5 customers are there. In the overall overall Ratnadeep, 5 customers are there. The time when I have entered around 9:30 p.m. I'm saying about 9:30, 9:45 p.m. approximately. At that time, only 5 customers are there. If I go at the same 9:45 to DMart, at least minimum to minimum 100 people will be there. Minimum, that is minimum. Maximum 10,000 people also will be there sometimes. Okay. One time I have seen, I have shocked myself whether I have went to DMart or whether I have went to Tirupati temple. The people are like that. I was not able to move my trolley also. I can't even move that one also. So simply I have left out that one and it came out. See, in this I can't purchase. The queue line in the billing counter, how the queue line is there now, minimum 1 hour it will take. Why that much of offers they are keeping and how this marketing strategies they're applying and all these things, if you observe, it is entirely different. For Ratnadeep also, it is having some profits. They are also making the profits. DMart also making the profits. They require customers are different. These people require customers are different. They are focusing on a different way. They are focusing on the different way. Though you get from one person a profit directly from Ratnadeep will focus on single person profit of 160 rupees. DMart will focus from 1% profit of 16 rupees only, but from 10 customers. Amount is 160 only. Now what happens? Instead of 1 customer, now 10 customers are there. When you have got the 10 customers into the DMart, they'll purchase only one product. No, right? They'll see automatically other products also. So they are increasing their things. These people they are not interested in that way. That is their strategy. This is their strategy. Each person will have a different strategies according to that, right? Now, so here I'm going to identify the type of people. I want to separate them, and according to the people, I want to make the offers. Who are having the high income, I want to make a separate offer for them. Who are having with respect to low income and spending score is high, for them I want to make a different kind of offers. For that, I'm going to separate the data. First, I'm going to check, is there any missing values? No missing values. Now I'm going to consider 2 columns. The column is, first one is index number of 3 and index number of 4. What is there in the index number 3? What is there in the index number 3, miss? 0, 1, 2, 3. That is annual score, annual income, and column 4 is spending score. I have taken only these 2 columns. Why, sir? Why you have considered only 2 columns? Why you have not considered this one, this one? Anyways, customer ID we can delete because it is unique values. This one will be deleted. Why you have not considered these 2? Why you have considered only these 2? Actually, you have to consider 4 of them now. Why you have considered only 2? Because I want to show you the scatter plot. I can't draw the scatter plot by considering 4 variables, right? So that is the reason I have considered only 2 variables. I want to show you the diagram before and after. The original scatter plot is this one, and after clustering, how the scatter plot will convert. To show you the scatter plot, so I have considered only 2 columns. In the real life, we have to take the 4 columns. Okay, in the real life, you have to consider 4 columns, guys. Just for showing you this scatter plot before how it is there and after how it has been converted. Now here, what I'm going to consider is X is equal to data set of ILOC of 3, 4. 3, 4 means annual income versus spending score. Only these 2 columns I'm considering, and I'm going to apply the k-means. So using the sklearn.cluster, import the k-means, and I'm going to take k is in range of 1 to 11. First, I will try with k is equal to 1, followed by k is equal to 2, followed by k is equal to 3, 4, 5, like this. I'm going to try with everything, and I'm going to calculate the WCSS value. Inertia, k-means dot inertia. K-means dot inertia means you are calculating the WCSS value, inter-cluster distance. Inertia means intra-cluster distance. And once you have calculated this one, now what you are going to do is just once you calculated the WCSS value, you are going to make a plot. And from this plot, I can observe the almost flatness has been started from here. This is the starting point, which is nothing but 5. Now, once I identified the k is equal to 5, I'm going to use the number of clusters is equal to 5. Initialization is equal to k means plus plus and some random state, and I'm going to fit and predict. Okay. Now what happens? It is going to divide into the entire data into 5 groups. Which record into which group means you can see like this. So this first record belongs to group number 2. Second record belongs to group number 3. Third record belongs to group number 2. Second group, third group, second group, third group, like this. Total 5 groups I'm having. What are the list of 5 groups means? First group is 0. Second group is 1. Third group is 2. Next one is 3. Next one is 4. Total 5 groups. Is that clear? Why 5 groups? Because you have identified k is equal to 5. So the entire data was divided into groups like this. And after dividing the groups like this, you are going to separate the data which is related to third group, group number 3. Separately, if you want, miss, you are going to write like this. By writing like this, you are going to get what is exactly group number 3. In the group 3, what are the records are there? In the group 2, what are the records are there? In the group 1, what are the records are there? In the group 0, what are the records are there? Like this, you can identify. Is that clear, guys? Clear? Any questions? Is there any questions with respect to k-means? How it is going to work and coding part? Just it is going to group. Yes. There, which is having with respect to either overfitting or underfitting, which is the best k value. Done? Any questions, online students? Yes, finally, after dividing the groups, now you have identified which groups belongs to which one. For example, like this. Now, this group says, what is this group is? With respect to their annual income is low and their spending score is high. If you observe the spending score, it is more than 60. Their annual income is less than 40. So this spending score is high and annual income is low. Now for this one, where annual income is very high, X value is very high, but Y value is less. Means this group has with respect to high annual income, but low spending score. Now I'm focusing only the group which is having with high spending score, this one and this one. These both groups are having high spending scores, out of which this group is having low income and this group is having high income. Now what I'm going to do, this group of people, for these people, I'm going to make some kind of offers. We are going to send the SMS that if you make buy one biryani and get one more biryani free, something like this. If you give more number of offers which will attract them, then only they'll spend. For normality, they'll not spend. Whereas these people, if you give just for biryani, buy one, get one. Biryani, buy one, get one. This offer is for these people. For these people, for biryani, you'll get a discount of 50 rupees. For these people, it is satisfied. So different type of people, different types of with respect we are going to do. Means to be more precise, we are identifying the different group of people, and based on the different groups of people, different types of offers we are going to create. Right? Is that clear? Sir, how we can know which variables and which futures has to be considered? All the futures you have to consider. Here I have taken, for your example, I have taken the only 2 columns. The reason behind 2 columns is scatter plot. Before to the scatter plot and after scatter plot. I want to show you this one. In order to show you this scatter plot, I have taken only 2 columns. But in real life, you don't require the scatter plot. So directly you are going to consider the 4 columns. For example, this data set was given in the real life. Just you have to drop the first variable and remaining 4 variables you have to consider. All the input variables you have to consider. And you know future selection technique, right? So common future selection technique you are going to apply, that is filter methods, only the filter methods. Embedded methods you can't apply because it is not with respect to any model. After the model, future importances is not going to give. Only the filter methods you are going to apply. Apply the filter methods, do the data cleaning, and data wrangling common. For example, this column you are considering, you have to convert encoding. Otherwise, how you can apply the distance formula? Distance formula you have to apply means male minus female whole square. How you can do? You can't apply this logic, right? So first you have to do the encoding, data cleaning, data encoding, and future selection. Everything is common. Whatever you are going to do before to the model, everything is common. No difference. Before to model, nothing difference is there. The difference will be only in the modeling. Is that clear? Yes, scaling also compulsory. Exactly. Scaling is compulsory because it is working on the distance formula. Scaling is compulsory. Manish. Sir, it is just up to plot, or we can predict on the any new data also. Yes, using this, you can predict on the new data also. But here there is you are not able to compare between the your train accuracy, test accuracy like this. You can't take. Train accuracy, test accuracies will not be available. But you can predict on the new data to which group it belongs to. For example, this is one group. This is the scatter plot. In this scatter plot, this is one group. This is one group. For this group, this is the center. For this group, this is the center. Now a new record is there. This record is there. Now what you are going to do? You are going to identify the distance from here to this center, from here to this center, and which is having the least one. This record belongs to that group. Simple. Which distance is low, that it is going to belongs to that group. Is that clear? Done. Any questions still? So in the tomorrow's class, we are going to do the hierarchical clustering. Okay, next type of clustering technique called as hierarchical clustering and DB scan clustering. These two type of clustering techniques we are going to apply in the tomorrow's class. And we'll see what is the difference between the hierarchical versus k-means clustering. And when we have to apply k-means, when we have to apply hierarchy, all these things we are going to see in the tomorrow's class. Is that clear? Done. That is the end of the session. And you can practice. I'm just uploading the notes. No evaluation. No evaluation. That is the, because in order to evaluate, original answer should be there, right? If I'm having the original answer and what is the model predicted answer, I can compare. Original answer only is not there. From where I have to compare. Right? What is the importance of? See, I think you only have sent the mail. Okay. So actually in the real life, the random state number will not have any importance because anyways, we are going to apply the cross validation. Since one of the student has asked me, sir, how we have to, as the random state changes, accuracy also changes, how I have to calculate the best random state number, I have shown that one. But if you select whether whatever the random state number, CV is going to be the same now. Accordingly, we are going to modify. Right? Yes. Still any questions? Future selection and PCA, everything was uploaded, right? Now I have to upload next. Oh, Flask I have not uploaded. Huh? Yes. Guys, model deployment in Flask. I have uploaded the notes. And along with that, I'm going to upload the clustering notes also. That is today's class. Okay. Done. PC and that we say in the NLP. I will explain. LDA. One second, slowly. Same, yeah, how you have handled in the other algorithms in the same way. Okay, from where you got this? What is this?